minus 5 to both sides, you become minus 5, and you take away the 5, and then the negative remains. And so it's like this now, negative x is greater than negative 5, and then negative x, hold up, oh, you gotta get rid of the negative 1 in front of the x, so negative x over negative 1, and you gotta do the same to both sides, so it's gonna be negative 5 over negative 1, and then x is dragged down by itself, and these two negative cancels out, and 5 divided by itself is going to be 5, so it's going to be 5. Negative's going to cancel out, negative's going to cancel out, negative's going to cancel out, and 5, any number over 1 is just going to be the top number, any number over 1 is going to be top number, any number over 1 is going to be top number. Numerator, numerator, numerator. And the domain is x is greater than negative 5. This means that if we put any value of x that is less than 5, we would end up with the positive value inside our log. So the goal is a positive number, positive number, positive number. Any number less than 5, any number less than 5, any number less than 5. A whole bunch of numbers, the second they get to 5 or they're bigger than 5, then we gotta stop. The second they get to 5 or bigger than 5, we gotta stop. The second they get to 5 or bigger than 5, then we gotta stop. Okay? And find the domain of the logarithmic function log base 2 parentheses 2 plus x squared. Okay. To do this, hold on. Alright, based on definitions of logs, the inside of this log has to be positive. Same. Alright, note how on this problem the inside of the log is squared, so no matter so no matter what we plug in for x, the inside will always be positive or 0. Since we only have positive values inside the log, our only restriction is where the inside would be 0. Ugh. Okay, I can't really think of a perfect analogy, but just think 2 plus x, and everything in here is like perfect, and all numbers work except for 0. So 0 is basically like common sense. 0 is not positive or negative. 0 is not positive or negative. 0 is not positive or negative. So nothing can be 0. And so yeah, just think of this. You can use every number except 0. You can use every number except 0. Every number except 0. Every number common sense not 0. Every number common sense not 0. Every number common sense not 0. Now I don't really know if that's right or not, but that's like my analogy for the situation. Positive values, anything that's a positive number, anything positive number, anything positive number. And 0 is like default, you're supposed to automatically know 0 is not positive or negative, 0 is not positive or negative, 0 is not positive or negative. So you can't use it and stuff. Alright, 2 plus x cannot equal 0, and that's what we got from this sentence. This whole sentence gave us cannot equal 0, cannot equal 0, cannot equal 0. So, well, in order, it is 2 plus x, drag it down, 2 plus x, drag it down, 2 plus x, drag it down. And then this last sentence, cannot equal 0, cannot equal 0, cannot equal 0. Common sense, common sense, common sense. Okay, then you gotta solve it. So, let's solve it. So we gotta put x by itself. So minus 2, x by itself, x by itself, x minus itself by itself, minus 2, minus 2, minus 2. And x cannot equal negative 2, x cannot equal negative 2, x cannot equal negative 2. And that is the domain of this function. The domain is all real numbers except negative 2. All real numbers except negative 2. All real numbers except negative 2. Yeah, I should have did this in order. If I would have did domain and range and all that first, I would have been able to come up with an analogy, but I'll skip straight to logarithms. I did this before, but I just did logarithms after like 3 months. If I would have did it all in order, I would have come up with an example as to how you could use this, but yeah, I didn't. But okay, let's just continue. Yeah, that's why it's important to do stuff in order. Alright, inverse